एवरीवन, वेलकम टू फिजिक्स एनालिसिस यूट्यूब चैनल। आज का जो हमारा विषय है फॉर्मूले। सर फॉर्मूले का क्या करें? फॉर्मूले का कुछ नहीं करना है, बस उसके ऊपर जो सवाल है उनको करनी है। इफ़ यू मेमोराइज फॉर्मूला लिटरली you will forget, but if you solve problems based on the formulas, it will automatically memorize in your brain. Clear? So practice in solving problems based on the formulas. So what are the formulas are there in class 10 physics? I am writing here. Let us see at a glance. Okay, so first chapter is electricity. Based on electricity, let us see what are the all possible formulas. Clear? So at the very first beginning, when you start reading electricity, charge topic will come. Under charge topic, one formula is coming, that is Q is equal to plus minus NE. So I am writing here Q is equal to plus minus N times E. Where what is U? Q means charge, right? And plus minus is for positive or negative. Suppose two electrons are removed from an object. Okay, so what is the nature of charge acquired by that object? So this is the case of removal of electrons, means deficiency of minus sign, deficiency of electron. So it will give what? Positive charge, because here there is a deficiency of electron, deficiency of minus. So that will be positively charged, because positivity will be more, number of positive will be more. Clear? So here Q is equal to plus minus NE, where N is number of electrons. How many electron is actually given to the object or removed from an object. Okay? And E is the elementary electronic charge, the least possible charge. And by the way, least possible charge is not E. Further you will come to know quark is there, but as of now we will discuss E is the least possible charge, right? So as per quantization of charge, you will read that wherever charge is present, the amount of charge is the integral multiple of elementary electronic charge. So this is the integral multiple, where N is 1, 2, 3 dot E is equal to 1.6 into 10 to the power minus 19 coulomb, right? So this is for Q is equal to plus minus NE. Now further when you will read, current is coming. Current. So what is current? So current, about current, it is defined as the amount of charge flowing through a conductor, okay, through the cross section of a conductor per unit time, right? So I is equal to Q by T. Charge per unit time is called current. Clear? Here you can also write Q is equal to IT. Q is equal to IT. So main formula is I is equal to Q by T. From this formula you can also write Q is equal to IT. Clear? Q is equal to IT, cross multiplication, where unit of current is ampere. Unit of current is ampere. So you can write here 1 ampere is equal to 1 coulomb per second. 1 ampere is equal to 1 coulomb per second. Sometimes they are asking define unit of current. So in what way you will define unit of current? So this is the way. I is equal to Q by T as per by definition. Okay, I is equal to Q by T. So Q is measured in coulomb and time is measured in second. So 1 ampere is equal to, if charge flowing through a conductor is 1 coulomb and this flow is in 1 second, so you can say that 1 ampere of current is flowing through the cross section of a conductor. If suppose there is a conductor, okay, through the cross section of this conductor, if you see 1 coulomb of charge is flowing in 1 second, I mean per second, in every 1 second 1 coulomb of charge is crossing through this cross section of this conductor. So I must say 1 ampere of current is flowing. Okay, so 1 ampere of current means 1 coulomb per second. Always remember, this is how you can define 1 ampere. Ampere is the SI unit of current. Clear? Coulomb is the SI unit of charge. Okay, next formula is based on potential difference. Potential difference means V is equal to W by Q. V is equal to W by Q. This is the most important formula. Okay, so many numericals are coming on this formula. V is equal to W by Q. From this you can also write W is equal to VQ. So this formula we are getting here from V is equal to W by Q. What is this V? V means potential difference, voltage, and W means the work done. Alright, the work done, and Q means charge. Okay, so when I say one conductor is there, okay, and across the terminal of this conductor, V is the potential difference. V is the potential difference applied across the two terminal of this conductor. What does it mean? क्या मतलब हुआ इसका? That means the potential difference across the terminal of these two conductor is said to be 1 volt. If 1 joule of work is done in bringing 1 coulomb of charge from one point to another point, 1 coulomb of charge. So joule per unit coulomb. You know, you see here from by this definition, joule V is equal to W by Q. V means potential difference. Potential difference is equal to joule per unit coulomb. Joule per coulomb. So this is measured into joule, and this is measured into coulomb. This is measured into volt. So 1 volt, I am writing here, 1 volt is equal to 1 joule per coulomb. So this is also a question. Most of the time they are asking, define SI unit of potential difference. So this is how you can define SI unit of potential difference. SI unit is what? SI unit is volt. SI unit is volt. So what is the SI unit of potential difference? Volt. The potential difference across the two terminal is said to be 1 volt. If 1 joule of work is done, okay, in moving unit positive charge from in moving 1 coulomb of charge from one point to another point. So this is how you can define 1 volt. Clear? Okay, so this was the formulas up to here. V is equal to W by Q, so W is equal to VQ. Here I have written, and unit, this is how you can write. Okay, after when you move on, after potential difference, resistance and resistivity is coming, right? So what is this resistance and resistivity? So I am writing here, resistance may this resistance is coming after Ohm's law, right? But before that also we are reading resistance is the hindrance offered by the conductor to the flow of current. See, when you apply a potential difference across the terminal of a conductor, because of this, one electric field is set up inside the conductor. This electric field exerts a force on the electrons present inside the conductor, that movable electrons, right? And because of this force, electrons start drifting. Understood? Okay. So when the electron started drifting, we say that current is flowing, because this is directional. Okay, so here what I am saying, because of this drift in electrons, in a huge number of electrons, there is a possibility to collide. They collide to each other, in this flow, in this rush, they collide to each other. Because of this collision, hindrance offered, hindrance this collision exert hindrance, and this is the hindrance, we call it resistance. So resistance R is equal to, you can write resistance when you will further discuss. Okay, we are getting that resistance depends upon length of the conductor. If length is increasing, the resistance is also increasing. Okay, resistance is decreasing with decreasing length, right? Now area of cross section also, when resistance increases, area of cross section decreases, the area of cross section increases, resistance decreases. Understood? So by these two we are writing R is equal to rho into L upon A, where rho is what? Resistivity, L is length, A is area of cross section. So as you know that resistance is directly proportional to length of the conductor, resistance is inversely proportional to area of cross section, and combining these two we are writing R is equal to rho into L by A, where rho is the constant of proportionality, and here we are using rho in terms of specific resistance. We also call it resistivity. Okay, so R is equal to rho into L upon A, where R is resistance and rho is resistivity. And the difference between these two, while reading this chapter you will come to know. Resistance is the hindrance offered by the conductor, and resistivity is the characteristics of a conductor. It is the inherent property. Suppose, are you looking this chalk? So if I will break down this chalk into two parts. Both the part offer the same resistivity, but if I am talking about resistance will be different. Clear? Because its dimension is different. Its dimension is different. Okay, and you can see here by the definition, resistance depending upon dimension of the conductor, but resistivity is independent of the dimension of the conductor. Why? Because this is the inherent property. It is the fundamental characteristics of a material. So that's why it is independent of dimension. Clear? So I am not going in that. I am just here. This video is dedicated for formulas only. Okay, R is equal to rho into L by A. Here, from here you can also define resistance. How to define resistance? See, if L is equal to 1 meter, area of cross section of a material is 1 meter square. So you can write then R is equal to rho. Then R is equal to rho. This is how you can define resistivity. So how to define resistivity? I will say that resistivity of a material is actually resistance of conductor of unit length of unit area of cross section. Okay, suppose you have been given one material, one wire, let's say one conductor of unit length, जिसकी लेंथ जो है 1 मीटर है, एरिया ऑफ क्रॉस सेक्शन 1 मीटर स्क्वायर है. So what is this resistance? What the resistance it will offer? That is the resistivity of this material. So this is how mathematically you can define resistivity also. R is equal to rho when L is equal to 1 meter and area of cross section is 1 meter square. Okay. So this is up to resistance and resistivity. We have written the formulas. Now after that we are coming to Ohm's law. See, one scientist was there, George Simon Ohm. He performed several experiments in order to come to know whether there is a dependency of potential difference on current or current on potential difference there or not. So for that he performed a series of experiments and finally got a conclusion. So what was the conclusion? That conclusion is a statement, and that statement we come to know, that statement we know as Ohm's law. So what is that statement? What is that Ohm's law? I am writing here. See, let us suppose there is a conductor. Let us suppose there is a conductor of resistance R. Okay, V is the potential difference that is applied across the terminal of these two conductor. ठीक है, V is the potential difference that is being applied across the two terminal of this conductor. Then because of this V, I current is flowing. See, potential difference is the cause, current is the effect. Okay, if you want current, you need to set up, or you need to apply a suitable difference in potential, then only current will flow. Clear? Now so according to Ohm's law, V is proportional to I. V is proportional to I. This is Ohm's law. A student is writing V is equal to IR. No, V is proportional to I. This is Ohm's law. So what is Ohm's law? The potential difference applied across the two terminal of a conductor is directly proportional to the current flowing through it. Right? At constant temperature pressure, we are adding by this definition. Why? Because if the physical condition like temperature, humidity, pressure of the room where the experiment is to be conducted, in order to verify Ohm's law, so because of this resistance may get changed. So that's why we are taking at constant temperature pressure, right? So at constant temperature pressure, the potential difference applied across the terminal of a conductor, across the two terminal of a conductor, is directly proportional to current flowing through it. So this is how you can write V is proportional to I. Now in order to remove this sign of proportionality, we are putting here one constant. So that constant is V is equal to IR. Because of this constant, this Ohm's law will become V is equal to RI you write or IR you write. No problem. In books they are writing IR. So this is Ohm's law. Clear? Where R is the constant of proportionality, not I. Clear? Where R is the constant of proportionality and I is the current, V is the potential difference. And by this you can also write R is equal to V by I. R is equal to V by I means V is equal to IR. Clear? Remember, we are giving an overview of all possible formulas in class 10 physics, right? Okay, so this is Ohm's law. So many questions are there on Ohm's law. Okay, what are the condition? What are the condition of Ohm's law? What is the limitation of Ohm's law? Condition, limitation, and ohmic conductor, non-ohmic conductor, Ohm's law verification. Okay, graph is there, tables are there, circuit is ohmic circuit is there. So many questions. I am not going in that. Okay, stick to the formulas. So formulas V is equal to IR, that is V is proportional to R. Sorry, V is proportional to I. Okay, so R is equal to V by I. Okay, now after Ohm's law we are reading series combination and parallel combination. Okay, so students should know why to combine two or more resistor in series or parallel, whatever. Why exactly to combine? See, in order to increase or decrease the resistance, overall resistance of the circuit, we oftenly do so. Okay, in order to increase the resistance in the circuit, we consider series combination, or in order to decrease the overall resistance of the circuit, we consider parallel combination. So sometimes we do series also, sometimes we do parallel also, as per as our need. Clear? There is advantage of parallel combination on series. What are the advantages? That you will come to know after reading this electricity. Right? Here, by the way, I am writing the formulas. What is the net resistance when two or more resistors are combined in series? So under series combination, if you remember, we have come to a result that RS is equal to, suppose two or more resistors are combined in series. Let's say I am talking, okay, I have taken three resistance, R1, R2, R3. So let's say three resistors are there, and these three resistors are a part of a circuit. I mean, these three resistors are connected in series in a circuit. Then what is the net resistance of these three resistors? So R1, R2, R3. Simply you can write RS is equal to R1 plus R2 plus R3. Always remember that the net resistance, the resultant resistance of resistors connected in series is larger than largest. Suppose 1 ohm, 2 ohm, 3 ohm resistors are connected in series. So what is the resultant resistance? So 1 plus 2 plus 3, that is 6 ohm. So 6 ohm will always be greater than the larger one, that is 3. तो 6 जो है 3 से ज़्यादा होगा. Clear? So this is how you are getting the result under series combination. So in series what happen? Current will be same. Same current is flowing through each of the given resistance. Yes, there is a voltage drop different, है ना? So let's say V1 is the potential difference across R1, V2 is the potential difference across R2, V3 is the potential difference across R3. So potential difference will change. Here I will be same, current will be same, and V is changed. I mean V will vary. Clear? So RS means resultant net resistance when connected in series. चलिए अब पैरेलल की तरफ चलते हैं. लेट्स से n number of resistors are connected in parallel. So let's say 3 resistors I am taking. These 3 resistors are connected in parallel. Okay. So let's say this is R1, this is R2, and this is R3. Okay. And this is how current is coming. So current has got 3 different parts at this point. So some current would like to pass through this, let's say I1, and some current will pass through this, let's say I2, and let's say I3. Okay, again they will recombine here, and again I current will come up. Okay, I current is going at this point, and the current got 3 different paths, so they are going accordingly. Okay, and after that again at this point, all the 3 current recombine and coming out by this value I current. So let's say V is the potential difference that is applied across the 2 terminal of each of the given resistance. So clearly by figure you can say that sir potential difference is same across the 2 terminal of each of the given resistance, I mean resistor. But here potential difference was different, current was same. Here current is different, so here I will write I will be different and V is same. So potential difference is same. There is advantage that if suppose R1 stop working, though that doesn't mean R2 and R3 will not work. Okay, R2 and R3 will work as it is. There is no effect of dysfunctioning any of the. Okay, so what is the net resistance of a resistor when connected in parallel? So that will be Rp, 1 upon Rp is equal to, we will write R1 1 by R1 plus 1 by R2 plus 1 by R3. This is how we are getting the result. Yani reciprocal of net resistance will be equal to the reciprocal of each of the summation of the addition of reciprocal of each of the given resistance, I mean resistors. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear? So in a shortcut also you can write, suppose 2 resistance are there, so rather than writing 1 by R1 plus 1 by R2, you can write Rp is equal to R1 into R2 by R1 plus R2. Like that you can write. Suppose 3 resistors are there, that also you can write Rp is equal to R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. So this is how you can solve the numericals given to you, okay, in order to save your time. Okay, so this is for series combination, this is for parallel combination. In parallel combination, you remember the result will always be smaller than smallest. अब suppose 1 2 3 ओम resistors are given, है ना, R1 की वैल्यू 1 ओम है, R2 की वैल्यू 2 ओम है, R3 की वैल्यू 3 ओम है. इसमें सबसे छोटा रेजिस्टेंस कितनी है? 1 ओम. So the result when you will combine these three in parallel, so what result should come? The expected result will definitely be it is less than 1 ohm. Now got it everyone? Okay, so this is about series combination, parallel combination. Now let us go for energy part. ठीक है, after that electric energy, electric power topic is coming, so let's see that one. Electric energy. See how electric energy is being defined. E is equal to W. See what the work is being done by the electricity, that is only defined as electric energy. So moving a charge, electricity need to do some work. Okay, that work only is termed as electric energy. So electric energy E is equal to W, you can say. E is equal to W, and before, and you have read before that V is equal to W by Q. There W was VQ. So here you can write E is equal to W, that is equal to VQ. That is equal to VQ. How this VQ is coming? Why? Because why? Because V is equal to W by Q. Potential difference is equal to work done per unit charge. Work done per unit charge. From here W is equal to V into Q. So from here in place of W I can write, you can write VQ. W is equal to VQ. Clear? Now when you will remove this Q, when you will replace this Q by IT, you know Q is equal to IT. Q is equal to IT also. Okay, how this Q is equal to IT is coming? So I is equal to Q upon T. Current is equal to charge per unit time. So from here cross multiplication, Q is equal to IT. Okay, this Q I am replacing with IT. So I will write here V into I into T. So this is the formula. This become a formula. So E is equal to VQ is equal to VQ is equal to VIT. Now here either you replace V or replace I, and you will get the formula. Okay. So further let us extend. So V is equal to IR. If you will replace V as IR, so you are getting the result like this, I square RT. Clear? Because V is equal to IR as per Ohm's law. Now again if you will replace I, है ना, तो V is equal to जब IR, तो I is equal to what? V upon R. I is equal to V upon R. I is equal to V upon R. So in place of I will write V upon R now. So is equal to V into V upon R into T. So what the result we are getting? V square T upon R. So this is the all possible formulas based on electric energy. Okay. For electric energy, right, you will write E is equal to, है ना, E is equal to W is equal to VQ is equal to VIT is equal to I square RT. I square RT, that is equal to V square T upon R. So this is the all possible formulas based on electric energy. Clear बच्चों? E is equal to W is equal to VQ is equal to VIT is equal to I square RT is equal to V square T upon R. Remember, sometime in MCQ they are asking which of the given formula is not there for electric energy, है ना? So like that also they are making questions. So if you know proper, है ना, you can no more question will be left by you. ओके, सो इलेक्ट्रिक एनर्जी, आई होप इट इज क्लियर टू ऑल. इलेक्ट्रिक एनर्जी की जो यूनिट है ना बच्चों, वो है जूल. व्हाट इज द SI यूनिट ऑफ इलेक्ट्रिक एनर्जी? दैट इज जूल. दैट इज जूल. एंड किलो जूल मीन्स फॉर लार्ज अमाउंट ऑफ एनर्जी वी आर यूजिंग किलो. kJ, kJ means 1000 joule. kJ. Here commercial unit of electric energy we are taking kilowatt hour. Kilowatt hour. Okay, that also I am writing here only commercial unit, है ना, commercial unit. So commercial unit we are taking unit, one unit particularly, that is 1 kilowatt hour. 1 kilowatt hour. See, remember here kilowatt means 1000 watt, and this hour is also there. So by this watt, don't consider it, it's a power, it's a energy, electric energy. So let us extend this. ठीक है, तो 1 kilowatt hour you are writing 1 kilowatt into 1 hour. 1 kilowatt into 1 hour. So 1 kilowatt means 1000 watt, or watt is actually joule per second, and here 1 hour you will write 60 into 60 second. So this second will cut. So now what we are having left with? So we are having left with 6 into 6 36, 00 000. So this much joule we are getting. I mean, if you will write proper 3.6 into 10 to the power 6 joule, or 3.6 into 10 to the power 3 kJ, kilojoule. So this is also in this unit जो है most of the time we are using commercial. Kilowatt hour is the commercial unit of electric energy. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule, or 10 to the power 3 in kJ, kilojoule. Clear? So this is the commercial unit of electric energy. But SI unit of electric energy, SI unit is joule. Joule. ठीक है, सो SI यूनिट ऑफ इलेक्ट्रिक एनर्जी इज जूल, बट कमर्शियल यूनिट जो है दैट इज किलोवाट आवर. वाट आवर मीन्स वाट आवर. सो वाट आवर मीन्स जूल पर सेकेंड इनटू सेकेंड, that will be joule only. Watt hour is not a unit of power, it's a unit of electric energy. Okay, now let us go for electric power. Power means energy per unit time. Okay, now electrical energy consumed by an electrical agent, okay, per unit time, that is defined as electric power, electrical power of that agent. Electric power is defined P is equal to E by T. P is equal to E by T, that means E means electrical energy, so of course you will write W by T. So P is equal to, if you write E by T means work done per unit time, that is only power. Energy consumed per unit time, that is only power. Clear? So E is equal to P is equal to E by T is equal to W by T. W is equal to VQ by T. W is equal to VQ, and this VQ is equal to VIT by T. So TT will be cancelled out. So what we are having left with VI. So this is the main formula of power. So P is equal to VI. Now you can replace V or you can replace I. You will get the formulas. ठीक है? So let us see further. P is equal to VI means if you will replace V as IR, IR into I, that will be I square R. One more time, rather than writing I would like to write V by R. So here I will write V into V by R, that will, है ना? So here V square by R. So let's see. So P is proportional to, inversely proportional to R. Now here students are in dilemma. Sir, what to understand? Power is direct proportional to R. Power is here inversely proportional to R. How to solve? Because there is a question, okay, on this topic. Like I have seen so many questions on this topic that they are asking whose resistance is more, 100 watt bulb or 60 watt bulb. It depends on the connection, okay, whether it is series in parallel or in parallel. So you see this P is proportional to R we are getting when I is constant, okay na. If I जो है is constant and this P is proportional to R we are getting if V is constant. You treat if V is constant. So if V is constant, we are the result is P is inversely proportional to R. But when I is constant, we are getting P is proportional to R. Now when to get I is constant? Yes, in series combination. So this we are applying in case of series, and this we are applying in case of parallel. ठीक है? Why? Because in parallel potential difference is constant. ठीक है? So their potential difference will be same, V will be same. So in that case, when two or more when two bulb is connected in parallel, in that case voltage will be same. Yes or no? If voltage is same, then power will be inverse proportional. I mean power will be more with less than resistance. With less resistance. Suppose 60 watt power is there, its resistance will be more. ठीक है? तो less power will offer more resistance in parallel combination, and if you will go with series combination, so more power means more resistance. Why? Because here current is same. I hope it is clear to all. Okay. Next is power is that only. Okay, so this is the all possible formulae on power. I am here writing P is equal to, you first you write E by T, because it is the main term. That power is actually electrical energy consumed per unit time. So P is equal to E by T, that is equal to VI. That is equal to I square R, that is equal to V square by R. So this is the formula based on power. This is the formula based on power. What is the SI unit of power? SI unit जो है is watt, W. ठीक है ना? 1 watt is equal to 1 joule per second. This also you remember. 1 watt is equal to 1 joule per second. Here by this definition, one more result we are getting, that is E is equal to PT. E is equal to PT. E means electric energy is equal to power into time. Now yes, now you remember. This power is defined in watt and this time is defined in hour. So watt hour is the unit of electric energy. Watt hour is the unit of electric energy. When you will add more power, more watt, I mean 1000 of watt, so 1000 watt means 1 kilowatt, and then it will become 1 kilowatt. 1 kilowatt hour, where 1000 of watt I have taken. So if watt is taken 1000 of watt, then it will be 1 kilowatt. So 1 kilowatt of course is the unit of electric energy. Of course watt hour is the unit of electric energy. Clear? So this is the relation. This is the relation between electric power and electric energy. So what is the relation between electric power and electric energy? So that is E is equal to PT. E is equal to PT. See, most of the problems are there. See, many problems are there on this topic. Like suppose 2 bulb is there, 1, 2, 3 fan is there, 1 refrigerator is there. Okay, they are working 8 hours per day. So if the rate of cost of suppose 50 rupees, या फिर 2 rupees, 3 rupees, 5 rupees, then find out the total bill, electric bill at the month of, in the month of August, September, like that. So how to solve this type of problems? By this only. ठीक है? First you calculate the amount of energy consumed by all the appliances, okay, per day. You multiply this by 30, find out the number of days in which of the particular month they have given. Okay, suppose January to 31. Understood? So you multiply it by number of days, it will give you the total energy consumed. Okay, now find out the timing. Okay, so E is equal to PT. So by this way you can solve this type of problem. Okay, what the amount of energy you are getting, you convert it into kilowatt hour by dividing 1000. You will have the kilowatt hour. Now this much kilowatt hour, when you will multiply by the cost and per unit, so it will give you the total cost. Clear? So this is the electric power, electric energy. Okay, now here only last topic they have given heating effect of electric current. तो दोस्तों हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट इज एक्चुअली H इज प्रोपोर्शनल टू I square RT. And by the way, when I was discussing electric energy, this is coming under electric energy only, and this is also electric energy, है ना. In fact H जो है ना, in place of H they could ask you anything like electric energy, light energy, heat energy. Okay, what the heat energy is there, what the light energy delivered, or what is the electric energy. So in all three, है ना, you can go for electric energy. What are the formulas we have derived? All that many formulas are same, है ना, for heat, for electric energy, for heat energy, for light energy as well. So H is proportional to I square RT. See, one scientist was there, James Prescott Joule. He observed that when a current is allowed to pass through a wire, na, it become hot. Not all the wire, those who are the heating element. Okay, so why this happens? So this is due to heating effect of electric current. This is due to heating effect of electric current. Now in further investigation, he found that what the heat energy is being delivered by this wire, because of current is passing through it, is directly proportional to square of current, is directly proportional to resistance offered by the conductor, is directly proportional for how long current is being supplied, I mean T. So they combine all three and we have got the remarkable result. This result we known as Joule's law of heating. Okay, so that is H is proportional to I square RT. See, when you will remove this sign of proportionality by taking one constant K is equal to 1 for SI unit. Okay, so here we are getting H is equal to I square RT. So this is your Joule's law of heating. So this is all possible formulas based on electricity. I hope it is clear now. Okay, now next we shall move for light. Okay, so note it down. Now let us go for light chapter. Okay, our next topic is light. So light has two parts, reflection part and refraction part. Let us see first for reflection part. So in the very first beginning, when you will start reading this light chapter, some definited words, है ना, you will come to know that, like radius of curvature, focal length, है ना. So there जो है one formula is there, like R is equal to 2F, twice of F, or F is equal to R by 2. This is one of the formula. Okay, this radius of curvature, suppose this is the concave mirror, and this is the pole, and this x dash is the principal axis. C is the center of curvature and F is the focus. This dash is the aperture of this mirror, concave mirror. Let's say, just for example I am taking, so let us consider dash, let us consider a concave mirror dash and with pole P, focus F, center of curvature C, and principal axis x dash. अब here this P2 है ना, as you know, as per the sign convention that all the distances are measured from pole, so I will measure from pole. P to F, that is focal length. So PF is equal to here focal length, and P to C, PC is denoted by R, capital R. ठीक है, R means radius of curvature, F means focal length. Clear? So here it is observed that radius of curvature R, this is the R, this is the R, this R will be twice of this focal length. You can see here this and this. ठीक है ना, यानी कि R is equal to twice of focal length, that means F is equal to R by 2. So if in the numerical, okay, it is given that a radius of curvature of a concave mirror is 36 centimeter. So it is the focal length. So focal length will be radius of curvature by 2, R by 2. So that will be 36 by 2, 18. Clear? So this is one of the formula, R is equal to, but here don't forget to use sign convention, right? Like concave mirror is there, so radius of curvature it should be in minus. So for this it is negative. ठीक है ना? So put it minus sign also. So focal length will be in minus for this. ठीक है? So your result should come in minus, negative, minus 18 centimeter. Clear? So R is equal to 2F, यानी F is equal to R by 2. Okay. Next जो है, we are getting the mirror formula, that is 1 by F is equal to 1 by V plus 1 by U. This is the mirror formula. So what is the mirror formula? The reciprocal of focal length is equal to sum of reciprocal of image distance and reciprocal of object distance, where V is image distance, and U is object distance. Okay, and this is how you are getting the focal length. So 1 by F is equal to 1 by V plus 1 by U. Here magnification also you can get. So M is equal to H dash by H. H dash means height of image. H dash is equal to height of image, and H is equal to height of object. Clear? So M is equal to magnification also they are asking. ठीक है, we are getting in order to know the nature of image. ठीक है, तो M is equal to H dash by H is equal to minus of V by U in terms of object distance and image distance. So this is the magnification. Questions are coming on this based on reflection. If they are asking numericals, these two formulas are very important. One is for focal length, second is for nature. ठीक है, nature of image. So M 1 by F is equal to 1 by B plus 1 by U, and M is equal to H dash by H is equal to minus of V by U, where this minus of V by U is coming. With this formula we are taking in terms of in order to show the magnification in terms of image distance and object distance. I mean magnification M is equal to minus of V by U. Remember here minus is coming, in case of lens plus is coming. ठीक है, okay. So this is the formula, ठीक है, based on reflection topic. Now here one thing I would like to tell you is some students are confused in sir minus or plus, when to say real image, when to say plus image. See, I am telling you, minus, when you will get minus, है ना, you consider real one, real image. Minus means real image and plus means virtual image. Okay, अब suppose I am telling you M is equal to given plus minus 2. What does it mean? See, plus minus will tell you whether it is real or virtual. ठीक है, and this will tell you whether it is magnified or smaller. ठीक है, so this is telling the nature and this is telling the size. Clear? Okay. Now to arrive at this result, M is equal to H dash by H. See, in case of real image, object means height of image will be inverted. Yes or no? Inverted means negative, minus. That's why minus sign is coming. So and that is why in all possible minus answer we are getting, we are we are considering real image, and for all plus and all for plus sign we are getting virtual image. Clear? Because virtual image is we are getting upright, I mean erect. So erect size of image, that means positive value. So positive result is coming. That means positive means virtual image and negative means real image. Okay, so minus, don't be confused now. Minus means real, plus means virtual. Always remember, minus means real, virtual, plus means virtual. Clear? And this is working the same for in case of lens also. Clear? Minus means real, plus means virtual. And 1, 2, 3 decide the magnified, smaller or same. If suppose m is equal to 1, that means same size. Yes or no? If m is more than 1, that means the image is magnified. And if m is less than 1, that means image is smaller. That is the thing only. Working the same for lens also. Okay. Now let us go for refraction part. So I hope reflection part is done now. Okay. So let us go for refraction. Okay. See, when we start refraction topic na, one word is there, refractive index. बहुत ही confusing topic है. मतलब students are very confused in this refractive index. Let us decode the refractive index. See, firstly you are discussing Snell's law. Okay, what is Snell's law? Tell. Sine of angle of incidence is directly proportional to sine of angle of refraction. All right, suppose there is a medium and this is the line of interface separating two different media. Now suppose this is air and this is water. Okay, suppose this is water. So as you know, when light is coming from water to air, when light is coming from water to air, this is R and this is I. So as you know, when light is coming from denser medium to rarer medium, it bends away to the normal, and when light coming from rarer medium to denser medium, it bends toward the normal. Why it happens so? Because of change in speed of light. Okay, generally speed of light is more in rarer medium as compared to denser medium. Clear? Now this suppose this I indicate the angle of incidence and R suppose indicate angle of refraction. Now for a given pair of medium, okay, pair of media, sine of angle of incidence, this sine I is directly proportional to sine R. For a given pair of media, sine of angle of incidence is directly proportional to sine of angle of refraction. So sine I is proportional to sine R. So here when you will remove the sign of proportionality, you will get sine I is equal to, we need to take one constant here. So here one constant we are taking mu sine R, where mu indicate the refractive index of this second medium in which light is entering with respect to first medium. So that's why here in most of the case we are writing sine I is equal to mu to 1 sine R. So that means sine I by sine R is equal to mu to 1. Right? That means sine I by sine R, you can write mu to 1 means mu 2 by mu 1, and that's why we are getting the result mu1 sin I is equal to mu2 sin R. So this is one of the formula we are getting. mu1 sin I is equal to mu2 sin R. ठीक है, from Snell's law. Okay, what is the next जो है, what is the next formula for this, under this? So under refractive index, next formula is suppose normally है ना, mu is equal to c by v. Always remember this, mu is equal to c by v. Mu means refractive index. So refractive index is equal to c by v. C means where c is speed of light in vacuum, and this v is speed of light in a given medium. Okay, so this we are getting in terms of speed of light. Now if I will literally tell about something like speed of light in glass, what is the speed of light in water, let's say speed of light in glass. So when I will write mu g is equal to, then I should write c by vg. So mu g is equal to c upon vg, where see mu is equal to c by v, where c was speed of light and v was speed of light in medium, c was speed of light in vacuum. Here for mu g I will write mu g is equal to c upon vg, where vg is speed of light in glass, where mu g is speed of, refractive index of glass. So refractive index of glass is equal to speed of light in vacuum divided by speed of light in glass. So when you will put up this formula, you will get the refractive index of glass. Now this refractive index in glass, mu g, this we call it absolute refractive index of glass. What we call absolute refractive index of glass. ठीक है, okay. Now when we compare है ना two absolute refractive index, then we introduce relative refractive index. So this is the difference between absolute and relative refractive index. So when we compare refractive index of glass with respect to refractive index of water, like I am writing here mu gw. What does it mean? How to read this? Refractive index of glass with respect to water. So relative refractive index of glass with respect to water is equal to absolute refractive index of glass है ना by absolute refractive index of water. Absolute refractive index of glass by absolute refractive index of water. And now you know that mu g is equal to c upon vg, and mu w is equal to c upon vw. Now this c will cancel out. So now what we are having left with? So vw by vg. So in place of speed, in most of the numericals, they are not giving the absolute refractive index. Rather than giving the absolute refractive index, they are giving speed of light of the medium. So this way mu gw is equal to vw by vg, vw by vg. But in case of, with if you will go with the absolute refractive index, so mu gw is equal to mu g by mu w. So remember this we call it है ना relative refractive index. Relative refractive index of glass with respect to water. So relative refractive index of glass with respect to water. Okay, so this is what relative refractive index. Clear? Okay. Incident angle of incidence and this emergent angle, these two are also we are getting equal. So sin I and sin E, that will also will be cancelled out. So what we are having result? So 1 to 2, 2 to 3 and 3 to 1, we are getting 1 only. Okay, that means if any of the refractive index, okay, sometime I have seen in one sample paper, they have asked one question based on this. That's why we oftenly say that when you will solve more and more sample paper, then all possible questions जो है you will mug up. Okay, then no problem regarding your exam. In what way they will ask, let them ask, you can answer, because you know all about the concept. Clear? So if any of the refractive index they will ask, and you know rest of the value, you can easily find out. See, there sometimes they are asking refractive index of one medium with respect to third medium, या refractive index of third medium with respect to second medium, या refractive index of second medium with respect to first medium. Any of the value they will give, and they will ask you the third one, any of the value, any other value, rest of the value they are asking. So by this result you can get your answer. So this is all about refractive index. Now let us go for lens formula. Now let us go for lens formula. Okay. So in lens formula, as you know, this is the lens. Okay. So let's say this is the lens LL dash. This is focus FF dash, and this is 2F dash. ठीक है ना? So let us consider a lens with optical center O. FF dash is the focal length and 2F dash is the center of curvature. ठीक है? Now as per lens formula, we are getting 1 by f is equal to 1 by v minus 1 by u. Remember, here we are getting minus. We are having lens formula in minus 1 by v minus 1 by u. Okay. If you will go for magnification, so m is equal to s dash by h is equal to v by u only. This is the magnification. This is lens formula. Here v is image distance. Image distance means the distance from optical center. Suppose image is being formed this side, so that much distance will be from optical center to up to where the image is being formed. Up to that much distance that will be v. Okay, so v is image distance, v is image distance, and u is object distance, and f is of course focal length. ठीक है? The distance from O to F. ठीक है ना? That is focal length. So reciprocal of focal length is equal to reciprocal of image distance minus reciprocal of object distance. This relation between f, v and u, we call it lens formula. ठीक है? And for magnification, m is equal to, we are taking s dash by h, where s dash is the height of image and h is the height of object. Again, in terms of image and object distance, we are writing v by u. Here also the same thing. Okay, if m is 1, that means image is same. Okay, and if m is more than 1, that means image is magnified, and if m is less than 1, that means image is smaller. Okay, and if m is equal to negative, that means go for real image, and if m is positive, go for virtual image. And you know, real image means inverted and virtual image means erect. So when in the numerical they are asking find out the nature with the image distance, they are also asking you to find out to write nature of image. So see, actually nature of image depending upon the position of image, and that position of object depending upon position of object placed in front of the mirror. So sorry, in front of the mirror lens, what you call, in case of lens to lens, in case of mirror to mirror. So in front of lens, what is the position of object? Accordingly, we are getting the position of image, and that define the nature of image. So first you find out the focal length or image distance, whatever they are asking. If they also ask find out the nature, then you go for magnification. Magnification is equal to s dash by h is equal to v by u. Always remember, if m is 1, that means same size, and you can write same size image is formed. And if m is more than 1, you are getting more than 1, like 1.5 to 2.5, that means image is magnified. Magnified means height of image is more than height of object. ठीक है ना? Then only na image m you are getting more than 1. Okay, m is less than 1, that means image is smaller, diminished. Okay, and if m is negative, then real, m is positive, then virtual and erect. Okay, here in case of lens, they are also asking the power. What is the power of lens? See, power means converging or diverging quality of a lens. A lens, how much the given lens, up to how much it can converge, up to how much it can diverge, that is termed as power. So power is generally defined as reciprocal of focal length. P is equal to 1 by f. Unit of power, if you will go for unit of power, so we are taking diopter, but remember, if focal length is measured into meter, then only it is in diopter. So E is equal to always take in meter. If you will take in centimeter, so you need to multiply it by 100. So 100 by f you will write, then it will be in centimeter. This is for power. If you want to get power into diopter, so we are taking power into diopter, that's why you go for meter. So you convert 100 by f in centimeter, then you will get the power in diopter. Okay, so this is the all possible formulas, dear students, okay, in class 10 physics.